All right, guys, so in this part 2, what do we have? Find the resultant of a plus b plus c given a equals 4 at 45 degrees, b equals 3 at 180 degrees, and c equals 6 at 330 degrees. Well, you know that the cosinus of 45 will be equal to ax divided by a. So the adjacent side divided by the hypotenuse, so you end up to express ax. You do the same thing for ay with the sinus, same idea for bx and by as well as cx and cy, and you know that the resultant of rx is just the addition of the addition of ax, bx, and cx, same thing for ry, and so this is how you're able to find easily the expression of your resultant. Again, if you know that you have the magnitude of your vector u equal to square root of u square, ux square plus uy square, remember that is defined using a right triangle with the Pythagorean theorem. Okay, so let's try to practice a little bit. So if you suppose you follow a vector a equal 110 mass at 20 degrees, and you have a vector b equal 220 miles in length, in magnitude, at 225 degrees. State the magnitude in the direction of the resultant a plus b. So regarding the magnitude, it's pretty simple. What you need to do, express ax, ay, bx, by, following the same pattern that we did previously. And then we know that rx is equal to ax plus by, plus bx, sorry, and ry is equal ay plus by. Therefore, when you add ex and bx and ay and by, you will be able to find negative 52.2 and negative 118. To find the, oops, I made a mistake right here, my apology. So to find the expression of the direction, basically defining the angle theta, what you need to calculate is ry divided by rx, and then you calculate theta by using tangent to the negative 1 of ry divided by rx. Okay? So note that theta is a reference angle. Okay? Now that theta right here is a reference angle. So let's work on the problem number 6. Okay? All right, problem number 6. What do we have? I know I went a little bit fast on this second part, so please go back to the screen, pause where you had, in order for you to be able to copy and take note of what I've been written. You just need to go over there. You pause. You take the different note, and then you go back to the problem number 6. In this problem number 6, what we are looking at is state the magnitude and direction of the resultant vector a plus b plus c, given that a equals 4 with the angle, b equals 3 with the angle, c equals. So we are going to use what we know already, but if you want to recalculate that, you can. We know that the magnitude, the vector, will be defined with a rx component equal to 50.24 and ry component negative 0.172. So when I calculate the magnitude of r, which is represented like this or without the arrow, it's going to be called using the right triangle of the rx square plus ry square, and therefore end up to have the square root of 5.024 square minus plus negative 0.172 square, and I end up to have a r value of 5.027. Now if I want to know the direction, I'm going to calculate tangent theta, and tangent theta equal ry divided by rx, and so I know that theta is going to be equal to tangent to the negative 1 of ry divided by rx. I substitute the value, and I end up to have tangent to the negative 1 of negative 0.172 divided by 5.024 and end up to have a theta equal negative 0.20 degree, which is 358 degree. Now, effect of multiplying scalar and vector. First of all, we are talking about stretch. That means compress the vector. Okay, and then 2, reverse the vector. 2, reverse the vector. So if you have a vector A right there, and then you want to have 2A, which is 2 times the vector A, the direction is unchanged. Direction unchanged. So we're having basically, if I want to do that properly, I'm going to do this way. And right there, I'm getting a 1.5 inch. So now I'm going to graph 1.5 by 2, which is about 3. 1.5 and 1.5, 3. This is 2A. Okay, note 2A. Note that A plus A equal 2A. All right? If you have B, let's say you have B like this, we were like that, and then we go to half of B. Well, again, what I'm going to do is use to make sure it's pretty much okay. And right there, it's about a vector. Let's try to do this vector a little bit better. 1, 2 centimeter, it seems to be. So there we go. This is half of B. Okay, this is half of B. Half of B, the magnitude, half of the magnitude, but same direction. Half of the magnitude, but same direction. Okay, so pretty easy. I could even also present, if you have the vector A like that, and you're looking for negative A, basically it is representing this vector A in the opposite direction. So right now my vector is, let's say, almost 2 inches, so 2 centimeters or something approximately like this. All right, this is negative A. Opposite direction, but same magnitude. Same magnitude. Same magnitude, but opposite direction. Okay, same magnitude but opposite direction. Oops, I have a little problem right here. There we go. I'm sorry for that. Oh, again, I'm sorry. Okay, so let's continue. Now, where was I? So the dot product. Okay, the dot product. So the dot product, it's something that is very interesting. And let's talk about that now for a few seconds, okay? So we are going to look at this right here. So we are just going to apply that. So if I look at my practice for this problem number 7. We have 2i and 2g. Of course, I should have a little arrow above I and g, which are vector only purely in x direction or y direction, magnitude 1. And so if I'm calculating a times b, which is a multiplied by b cosinus of the angle theta, and I know that the vector A is defined as a 2, 0. Why 0 on G? Because they are telling me A equal to I, that's it. That means 0 G. And B is defined as 0, 3. I can easily work this out when I do 2, 0 multiply 0, 3. I know it's going to be the square root of 2 square plus 0 square, which is the expression of the magnitude of your vector A, multiplied by the square root of 0 square plus 3 square, which is the magnitude of your vector B, multiplied by the cosinus of the angle theta. And therefore, we end up to have a 2 multiplied by 3 cosinus of the angle theta. When we are doing the multiplication, we end up to have 0 right here. And so therefore, because basically we're having 2 times 0 multiplied by 0 times 3, and so we end up to have 0 equal 2 times 3 cosinus theta, which is 0 equals 6 cosinus theta, and that the only way it's equal to 0, that means the cosinus is equal to 0, and so that means the angle theta is 90 degrees. I can do exactly the same thing for the problem number 8. Okay, we are going to have 2, 3 multiply 1 negative 2, and that is going to be 2 multiplied by 1 multiply plus, sorry, plus 3 multiply, well, that was a plus, so 3 multiplied by negative 2 equal square root of 13 multiplied by square root of 5 multiplied by the cosinus of the angle. So negative 4 equals square root of 65, if I'm correct, multiplied by the cosinus of my angle. And so the cosinus of your angle equal negative 4 over square root of 65. And if you want to find the angle theta, you are going to take the cosinus to negative 1 of negative 4 divided by square root of 65, and you are going to end up to have an angle equal 119.7 degrees. How did I find square root of 13 and square root of 5? Well, square root of 13, I would like to remind you, it is square root of 2 square plus 3 square, and square root of 5, square root of 5, it is nothing less than 1 square plus negative 2 square. So please, when you're multiplying, basically what you did is 2 times 0 plus 0 times 3. I do it again. 2 times 1 plus 3 times negative 2. Okay? And this is right here the value of A, and this is right here the magnitude of B, which is the square root of the component on x squared plus the component on y squared of each vector. And then you take the square root, of course, following the Pythagorean theorem. So, guys, I think I've done with this section 7.6. Take your time, go slowly. Don't forget to pause when you take your note with the video, and see you in class to practice.